The basis of a range of a specific matrix under linear transformation is equal to the column space of said matrix. This is how we are going to solve for the basis of the range for these two different matrices here. And after we're done solving for the basis of their range, the rank, which is considered as the dimension of the basis of the range, will be determined. Here, we just simply need to start by coming up with the reduced row echelon form of these two different matrices. And after that, once we could identify which, after your reduced row echelon form, which of those columns, as we are using column space here, which of the columns contain leading 1 as considered to be our pivot columns, we're going to look at our initial matrix and determine the acceptable columns to be included in the basis of the range of T. Here, let's start with the, coming up with our reduced row echelon form of this matrix A. Since we're going to come up with a leading 1 here, of course, you can always multiply -1 to the entire row 1, but I'm just going to interchange here row 1 and row 2, so that when I have here 1, 1, -1, and 1, so I simply interchange them. I could just automatically add the two entries of the row 1. So row 1, I mean the column 1 rather, plus row 2 for a new row 2. Since we have here 1 plus -1 being 0, so you still have 1, 1, 0. 1 plus 1 is 2. Let's make this leading 1 by multiplying said row by 1/2. Then you have here 1, 1, 0, and then finally 1. This is not yet the reduced row echelon form because we need to make this 0 by multiplying -1 to row 2 plus row 1 for a new row 1 in backwards motion. This is 0, 1 here. -1 times 0 is 0 plus 1. -1 times 1 is -1 plus 1, 0. This is now our final reduced row echelon form of our first matrix. And as you can see, both columns, okay, we have this column here and this column here, contains a leading 1. This leading 1, there's also a leading 1. In short, going back to our initial matrix, both of these columns here, when formed as a vector, are comprises the column space of A. And that said column space of A is the basis of the range of T. In short, the basis here, let me write it here, the basis for the range of T for our first matrix are both columns here containing -1, 1, and 1 and 1, written in this manner: a set containing the vectors -1 and 1, and then 1 and 1. Close that. Or, if you would like to, you could write it in the form of vector -1, 1, and then 1, and then 1 here. This is the basis for the range of our first matrix. After that, we can now identify the rank of our linear transformation using matrix A. The rank is equal to the dimension of the basis of your range. Since our range contains 2 vectors, the rank here is 2 as well. So there are 2 vectors here, hence this is 2, and these 2 here are acceptable for the basis of, or for the range of T. Let's proceed to the second matrix here. Same thing, we are going to come up with its reduced row echelon form. First, let's make this a leading 1 by multiplying 1/3 to our row 1 so that our 3 will become 1. Here we have 1, and this is 2/3. -9, -6. Next is to make this 0 by multiplying 9 to our row 1 plus row 2 for a new row 2. We have 1 and 2/3 here. 9 times 1 is 9 plus -9, 0. Next, we have here 9 times 2/3, that's 3. Okay, we have here a divisor of 3, so that's 9. That's 3 times 2, 6. plus negative 6, 0 here as well. This is now the reduced row echelon form of our second matrix. We don't need to make this 0 or come up with that 1 because we already have here 0 rows at the bottom. And the only row with the leading 1 is this. Okay? Because this is not a leading 1. Okay? So with this, the basis for the range of T for our second matrix is the column space containing the first column. So we have here the set containing 3, 3, negative 9. Or in vector form, you have 3, negative 9. And with that, since again the rank of T is equal to the dimension of the basis of your range, the rank of T is equal to 1 since our basis for range of T contains 1 vector. So this is how we show the range and rank of a linear transformation involving matrices, specifically 2 by 2 matrices. Again, we used here the reduced row echelon form and the concept of the column space. By the way, before we end, these two bases for the range of a specific matrix is not unique, as we could have also another basis using the row space since we are using here the column space. Okay, so we could also have another basis, but what is sure now is regardless of what form, whether it's a column space or row space, the value of the rank will just remain the same. Thank you very much for watching.